Download this code from codegive.com, link in the description below. Certainly. MIT 6.S191 is an introductory course on deep learning that covers various topics, including convolutional neural networks, CNNs. This tutorial will provide an overview of CNNs, their architecture, and a simple code example using TensorFlow and keras. What are convolutional neural networks, CNNs? Convolutional neural networks are a class of deep neural networks primarily used for analyzing visual data. They are particularly effective for image classification, object detection, and other computer vision tasks. CNNs leverage the spatial structure of images and can automatically learn hierarchical features. Key components of CNNs. 1. Convolutional layers. These layers apply a convolution operation to the input, passing the result to the next layer. They use filters, or kernels, to extract features from the input image. 2. Activation functions. After each convolution operation, an activation function, like ReLU, is applied to introduce nonlinearity into the model. 3. Pooling layers. These layers reduce the spatial dimensions of the input volume, allowing the network to focus on the most important features. Common pooling techniques include max pooling and average pooling. 4. Fully connected layers. After several convolutional and pooling layers, the high-level reasoning in the neural network is done via fully connected layers, which output the final classification. 5. Dropout. A regularization technique to prevent overfitting by randomly setting a fraction of input units to 0 during training. CNN architecture example. A typical architecture for a CNN can be summarized as follows. 1. Input layer. 2. Convolutional layer plus activation, ReLU. 3. Pooling layer. 4. Convolutional layer plus activation, ReLU. 5. Pooling layer. 6. Fully connected layer. 7. Output layer with softmax activation, for classification. Example code. Let's build a simple CNN for the NIST dataset, handwritten digits classification, using TensorFlow and keras. Step 1. Install required libraries. Make sure you have TensorFlow installed. You can install it using pip. Step 2. Import libraries. Step 3. Load and pre-process the NIST dataset. Step 4. Build the CNN model. Step 5. Compile the model. Step 6. Train the model. Step 7. Evaluate the model. Step 8. Visualize training history. Conclusion. This tutorial provided a brief overview of convolutional neural networks, CNNs, a standard architecture for image classification tasks. We implemented a simple CNN using TensorFlow and keras to classify handwritten digits from the NIST dataset. You can extend this model to include more layers, use different data sets, or experiment with hyperparameters to improve performance. Additional resources. MIT 6.S191 official website, http://introtodeeplearning.com. TensorFlow documentation, https://www.tensorflow.org. Keras documentation, https://keras.io. Feel free to reach out if you have any questions or need further clarification on any topic.